The world watched with bated breath as the James Webb Space Telescope embarked on an unprecedented journey into the farthest reaches of our solar system. In a groundbreaking mission, it ventured into the icy expanse of Pluto, a realm never before explored by spacecraft. The images it transmitted back were nothing short of breathtaking, revealing intricacies of Pluto previously unseen. From towering peaks to serene valleys and ancient craters, the telescope unveiled a landscape that ignited the imagination. And then there was Pluto's enigmatic icy heart, a cosmic enigma that continues to puzzle scientists. Why is NASA revisiting Pluto with the James Webb Space Telescope, and what does this exploration mean for future missions to the outer edges of our solar system? Each leap in innovation and technology adds a new chapter to our ongoing saga of space exploration. Reflecting on our journey, it's clear that we've made tremendous strides since Neil Armstrong's historic moon landing. Yet, the vastness of the cosmos and our limited understanding of it serve as a humbling reminder of how much there is left to discover. This is where NASA's ingenuity shines brightest, with innovative projects and instruments pushing the boundaries of what we know. The James Webb Space Telescope, JWST, soared into space with the mission of unlocking the secrets of distant worlds and peering into the very origins of the universe. It stands as a monumental continuation of NASA's previous endeavors, offering a thrilling opportunity to delve deeper into cosmic mysteries that have intrigued us for generations. From the explosive birth of the universe to the formation of our own solar system, our quest extends even further as we eagerly seek answers to the tantalizing question of extraterrestrial life beyond Earth. Could our expanding knowledge of the solar system herald a new era of exploration? Might the revelations brought forth by the James Webb Telescope compel us to reconsider the fundamental underpinnings of our understanding of the cosmos? These thought-provoking inquiries prompt a reassessment of our current comprehension, particularly regarding Pluto's classification as a dwarf planet. Thanks to the groundbreaking discoveries of the New Horizons mission, our understanding of Pluto has undergone a remarkable transformation. This billion-dollar investment has propelled NASA's endeavors to unprecedented heights, enriching our comprehension of this distant icy world. Prior to the New Horizons mission, our knowledge of Pluto's surface was scant at best. The most detailed image available, captured by the Hubble Space Telescope in 2002, depicted a captivating array of colors adorning Pluto's surface, shades of orange, white and black, alongside a conspicuous bright spot that captured the imagination of scientists. With only limited details provided by the Hubble Space Telescope, unraveling the mysteries of Pluto was akin to attempting to solve a puzzle with only a handful of scattered pieces. Then along came the James Webb Space Telescope, venturing into Pluto's orbit and capturing a series of breathtaking images that revolutionized our understanding of the distant planet. It was akin to receiving an exclusive backstage pass to a mesmerizing magic show, revealing previously hidden wonders in all their splendor. These images didn't just captivate scientists, they ignited a global wave of curiosity and wonder, sparking newfound passion for the mysteries beyond our own cosmic neighborhood. In July 2015, the New Horizons mission achieved a significant milestone by conducting a close flyby of Pluto and its myriad moons, transmitting back to Earth the first detailed snapshots of this distant celestial body. This historic moment marked a significant leap forward in our exploration of space, furnishing astronomers with invaluable data previously beyond reach. The triumph of the New Horizons mission paved the way for further exploration of the expansive Kuiper Belt. Recognizing the pressing need for a comprehensive understanding of distant celestial bodies, NASA turned its attention to planets situated between Neptune's orbit and nearly 50 astronomical units from the Sun. The mission's most notable highlight was undoubtedly its close encounter with Pluto and its largest moon, Charon. Moreover, New Horizons captured clear images of Pluto's 4 additional moons: Nix, Hydra, Kerberos, and sticks. Over the course of 15 months, the spacecraft diligently collected a wealth of data, culminating in the successful acquisition of 6.25 GB of invaluable information by October 25, 2016. But why does this vast trove of information matter so much for NASA's understanding of Pluto? Following the collection of data, the findings from the New Horizons mission proved to be so remarkable and distinct that scientists had to devise new cutting-edge data models to make sense of the results. Over time, it became evident that Pluto exhibited significant surface and atmospheric dynamics, defying initial expectations. Despite being reclassified as a dwarf planet, Pluto showcased a dynamic character, evolving at a pace that prompted NASA to rethink and refine existing knowledge about this captivating celestial body. NASA's high-resolution images of Pluto unveil captivating insights into this distant dwarf planet. One particularly striking feature is Pluto's heart-shaped region, aptly dubbed the Heart of Pluto. Scientifically known as the Sputnik Planitia, this geological marvel profoundly influences many of Pluto's surface characteristics. Remarkably, this heart-shaped expanse isn't warm and pulsating, but rather cold, icy, and nearly frozen. It's essentially a colossal nitrogen ice sheet spanning over 1 million square miles. The presence of this immense nitrogen glacier at the heart of Pluto holds significant implications, particularly in driving a phenomenon called true polar wander, which causes shifts in the planet's spin axis. Prior to NASA's mission, scientists were unaware that Pluto's heart-shaped basin aligns directly opposite its largest moon, Charon. This realignment of Pluto carries intriguing implications, especially regarding the dynamic interplay between Pluto and Charon. In simpler terms, the alignment of Pluto's heart-shaped basin with the tidal axis between Pluto and Charon implies that the heart's presence influences the planet's orientation. Essentially, the gravitational interplay between Pluto and Charon, coupled with the presence of the Sputnik Planitia, has led to a slight tilt in Pluto's axis. This newfound insight helps us understand why Pluto is such a dynamic and captivating world. Despite its inhospitable conditions for humans, Pluto's icy surface and the vast nitrogen glacier at its core contribute to its distinctive nature. These characteristics extend to its tendency to tilt due to imbalances in its mass. Pluto's substantial mass, along with the gravitational influences of its moons, can induce a phenomenon known as true polar wander. This occurs when a planet aligns its rotation axis with a more favorable orbit. However, the presence of the thick ice sheet alone isn't adequate to trigger such a significant reorientation. While the massive ice glacier does add to Pluto's mass, it's not the sole factor driving the dwarf planet's tilt, nor the only force exerting strong tidal influences. In a remarkable development, recent technological advancements have enabled scientists to probe deeper into Pluto's enigmas, leading to a groundbreaking revelation. Previously unknown to us, Pluto harbors a hidden ocean beneath its icy exterior. This discovery is revolutionary, challenging our prior scientific assumptions about the planet's structure and origins. The presence of an ocean as one of Pluto's internal features fundamentally reshapes our perception of this distant world, likening it to other oceanic moons in the solar system such as Titan, Enceladus, and Europa. While there's currently no evidence to suggest the possibility of life existing in Pluto's ocean, the mere existence of such an environment prompts us to ponder the potential habitability of extraterrestrial realms. This breakthrough prompts us to consider the potential for life beyond our planet and underscores the importance of investigating oceanic worlds within our own solar system. NASA acknowledges that, despite the lack of definitive evidence, the hypothesis of extraterrestrial life remains a valid avenue of exploration. Another significant finding, courtesy of NASA's Cassini mission, revealed the presence of a phosphorus-rich ocean beneath the icy crust of Saturn's moon Enceladus. This discovery sparked ongoing discourse about the potential for extraterrestrial life, as phosphorus is crucial for the formation of DNA and RNA, the building blocks of life. While Enceladus remains a promising target for astrobiological research, assessing the habitability of Pluto presents a unique challenge. Unlike Enceladus, which has been extensively studied, Pluto's complexity lies in the limitations of current imaging technology. While our instruments can capture clear surface images, they lack the capability to delve into Pluto's potential habitability. The inability to accurately determine the chemical composition of Pluto's subsurface water hinders our ability to expand knowledge and definitively ascertain its potential to support life. Despite NASA's ongoing efforts to explore icy worlds like Pluto, the absence of equipment to assess the nutrient content of its oceans remains a significant obstacle. Nevertheless, the significance of studying Pluto should not be underestimated. The planet offers invaluable insights into various realms of planetary science, ranging from deciphering its geological features to unraveling its origins and evolutionary history. Each new revelation enriches our understanding of the solar system and fuels our curiosity about the potential for life beyond the confines of Earth. As we delve into the high-resolution image of Pluto, a plethora of hidden features emerges, some of which may leave you astounded. Among these remarkable discoveries is a lake nestled within a mountain range just west of Pluto's iconic heart. Spanning approximately 20 meters wide, equivalent to about 32 kilometers, this peculiar body of liquid now appears frozen. Yet, scattered clues across the dwarf planet's surface hint at its past existence as a flowing lake teeming with a mysterious substance. The presence of a lake on Pluto is all the more astonishing given its extreme cold, with temperatures plummeting to minus 230 degrees Celsius or minus 382 degrees Fahrenheit. While the exact composition of the liquid remains unclear, scientists speculate that it may have been liquid nitrogen. Billions of years ago, liquid nitrogen likely played a role in sculpting riverbeds and intricate gullies, such as the stunning landscape depicted in the photograph. Pluto's fluctuating surface temperatures and pressures enable liquid nitrogen to pool and flow despite its distance from the Sun's warmth. As the dwarf planet orbits closer to the Sun, subtle warming prompts solids to transition into gas, and under certain conditions, this transition may result in the formation of liquid nitrogen, giving rise to these unexpected features. Pluto continues to present another puzzle as scientists examine its hazy atmosphere, vividly illustrated in the received images. While Earth's atmosphere differs markedly from Pluto's, the composition of gases enveloping the distant dwarf planet adds to its allure and complexity. It provides scientists with invaluable insights into planetary atmospheres and the broader dynamics of celestial bodies within our solar system. Pluto's atmosphere is incredibly sparse, approximately 880,000 times thinner than that of Earth. It is thought to originate when sunlight vaporizes surface ice, triggering a reaction with methane and other molecules. This reaction produces a complex blend of hydrocarbons, resulting in a haze akin to smog. These haze particles, which scatter blue light, gradually settle through the atmosphere, forming intricate horizontal layers extending to altitudes surpassing 120 miles or 200 kilometers. As Pluto drifts farther from the Sun every 248 years, its atmosphere continues to freeze, giving rise to a peculiar kind of snow that gently descends and adheres to the planet's surface. However, the precise nature of these snow particles remains a puzzle. Scientists are still striving to determine whether the snowfall is granular or flake-like, and whether it might manifest as blizzard-like winds or a soft snow swirling amid the dense, frigid mist. Thus far, scientists have observed what appears to be a layer of nitrogen snow condensing from the atmosphere and settling on the surface, particularly in regions like Tombor Regio. This observation holds promise for unraveling the enigma of snowfall on Pluto. While investigations continue, one of the most remarkable sights on Pluto is its snow-capped mountains in the southern hemisphere, reminiscent of Earth's Alps. However, upon closer scrutiny from the International Space Station, these mountains reveal striking differences. They are comprised of water ice as solid as granite, adorned with a coating of frozen methane snow. Some of these towering peaks can soar to heights of up to 2.2 miles or 3.5 kilometers above the surrounding landscape, akin to the Rocky Mountains in North America. While the presence of mountains on Pluto isn't surprising, scientists are puzzled by their formation. On Earth, mountains typically result from either tectonic shifts or volcanic activities. However, Pluto's mountains exhibit no signs of such processes. Instead, scientists propose that these mountains are shaped through a phenomenon known as sublimation. Erosion through sublimation occurs when frozen materials like nitrogen or methane on Pluto's surface are exposed to sunlight, transitioning directly into gas. This process erodes the surrounding terrain, leaving behind towering, jagged peaks. Interestingly, Pluto seems to undergo periodic surface regeneration in certain areas. Evidence suggests the flow of a cold, slushy substance resembling lava over its landscape at various intervals. This peculiar phenomenon, known as cryovolcanism, involves the eruption of icy volatiles such as water, methane, and ammonia, rather than molten lava. Similar cryovolcanic activity has been observed on other icy moons like Enceladus and Europa. The presence of mountainous regions with pits or depressions on their surfaces points to Pluto's cryovolcanic activity. A notable example is Right Mons, WMS, a mountain in Pluto's southern hemisphere that towers 2.5 miles, 4 kilometers, above its surroundings, featuring a wide summit depression. Close-up images suggest that this feature may be an ice volcano, potentially the largest of its kind in the outer solar system. Another fascinating discovery on Pluto's surface is the vast expanse of dunes resembling those found in Earth's deserts, stretching across the western edge of its heart-shaped region. These dunes pose yet another enigma waiting to be unraveled, offering a glimpse into extraterrestrial landscapes untouched by human footprints. While Pluto's surface features, including its dunes, bear resemblance to those on Earth, they harbour unique characteristics. On our planet, dunes are formed by wind movements that transport and deposit particles in specific areas. However, Pluto's dunes exhibit distinct traits. They may have originated not only from wind action, but also from the sublimation of nitrogen ice, causing grains of methane ice, akin to sand, to be lifted by ascending gases and carried away once airborne. Moreover, Pluto's dunes are considerably larger than those on Earth, with some towering as tall as mountains and spanning for many miles. This is likely attributed to Pluto's lower gravity, facilitating easier particle transport and the formation of these impressive features. Another captivating aspect of Pluto's terrain is the presence of iceberg-like structures scattered across its heart-shaped region. These structures appear to be fragments of ice that have detached from larger formations, each measuring 1 to several miles wide and seemingly floating across the frozen surface below. Scientists suspect these icebergs are composed of frozen water, as water ice is less dense than nitrogen ice. When they break off and are propelled into Pluto's heart, possibly through glacial movements, they are subjected to the motion of the underlying nitrogen ice, resulting in the distinctive shapes observed in this region. The cell-like formations covering Pluto's heart also offer insights into the planet's geological processes. Resembling a phenomenon called convection, these formations occur when a fluid is differentially heated, whether by the sun or a boiling kettle. This convection process is indicative of Pluto's dynamic and evolving surface, shedding light on the intricate interplay of forces shaping this distant world. The presence of convection on Pluto suggests that something beneath its heart-shaped region is warmer than the surface, causing the frozen nitrogen plates to gradually shift over time. Upon closer examination of the images, scientists note that the icebergs tend to cluster around these convection cells, likely being pushed towards the edges by underlying forces. Scientists continue their investigations into these formations and other distinctive features of Pluto, hopeful that answers to the lingering mysteries surrounding Pluto will soon emerge. Each time we cast our gaze upon Pluto, it unveils something new to behold. And Pluto is merely one of potentially hundreds of dwarf planets residing in the Kuiper Belt. Contemplating the wonders that may exist on other dwarf planets like Haumea, Makemake, or Eris, which remain unexplored, fills us with awe. Perhaps, in the future, we'll have the privilege to behold their icy splendor and unlock the enigmas they harbor. With the advent of the James Webb Space Telescope, we stand on the cusp of a new chapter in space exploration. The classification of Pluto as a dormant planet is swiftly fading into obsolescence as NASA unveils crisp, intricate images of intricate geological formations recently unveiled on its surface. These breathtaking visual revelations signify a pivotal breakthrough, offering glimpses into the dynamic essence of this distant realm. It's truly remarkable to consider that mere gigabytes of data can open up a realm of boundless possibilities for us. The wealth of knowledge amassed through missions like New Horizons and the James Webb Space Telescope provides fresh insights into the mysteries of our cosmos. With each newfound revelation, we draw nearer to comprehending the intricacies of celestial bodies like Pluto and unraveling the secrets they guard. Indeed, the prospect of what lies ahead in our cosmic exploration is both exhilarating and humbling. As we continue to push the frontiers of our understanding, the journey into the depths of space promises to be as captivating as it is enlightening. Thank you for joining us for another episode of Cosmic Discovery. While you're still here, don't forget to click the video on your screen for more awe-inspiring content like this one.